How are you doing? Mrs. Johnson here. Today we are going to talk about order of operations. So we're still working out of chapter 0, moving on to lesson number 3, order of operations. And just a little side note, I already started to make this video once and got some notes started. And then my computer glitched out on me and it quit recording and I lost the recording, so I had to start over again. So this is going to be a great opportunity for you to practice your pausing and starting skills when you watch a video. Because what's going to happen is I've already got the notes in my notebook. They're already there. Instead of rewriting them, because I've already started them, I am just going to cover them up and let you write them down. So like I said, it'll be a great opportunity to pause when you need more time to copy down some notes. So here we go. So I've got my math notebook. I prefer to use a math notebook, nice and sturdy composition book. I know Mr. Cummings uses just blank pieces of paper, because that's what works for him. So once again, we're talking about this whole purpose and process is to find what works for you. I've got my table of contents. I add them as we go, and my page numbers. And you'll notice I only write on the front of the pages because I do use the colorful, really cool pens. And so because I'm using those pens, I don't want my stuff to bleed through. You can see what's on the front of this page. So I really only focus on the front of my page. So there's the first one. And now we are on to order of operations. So first thing we're going to start with is our title, order of operations. So if you need a moment to write that down, go ahead and pause this video now. And when you're good to go, we're going to continue. So next order of business is writing down our essential question. Now for this one, I actually wrote down 2 essential questions because I feel like there are 2 things that we need to know about order of operations. First thing is obviously what are the order of operations, and kind of going a little bit further, how do we use them? And then in addition, why do we use order of operations? And I really like this question, and I like to explain this question. I don't know if any of you guys are on Facebook, but I've seen a lot of mathematical expressions that people have been evaluating on there, and then like arguments break out over the correct answer. And the people who are correct are the ones who refer to the order of operations. Okay, so what are the order of operations? Well, first thing we need is a vocab. So once again, here is kind of the vocabulary that I picked out of this lesson. You might have some other words that you want to define, but I just was thinking the order, and then in specifically order of operations. So the set are the series of steps that we use to evaluate an expression containing multiple operations. And I had a little mistake there. Once again, I'm human. I make mistakes. So I crossed it out. But if you need a moment to pause this video so you can write that down, there you go. And then what are the order of operations? So we like to use an acronym. You might have heard a couple of different ones, whether it's PEMDAS or GEMDAS or a couple other of acronyms, but we use the acronym GEMS. And what does GEMS stand for? The G is our grouping symbols. And there are several grouping symbols that we use. The first one is parentheses. That's probably the one you see the most often. The next one is brackets, and brackets a lot of times are used when you have more than one set of parentheses. It helps you differentiate between the different kinds of parentheses. The next one is sometimes mistaken for not a grouping symbol, but it does act as a grouping symbol, and that would be our fraction bar, and we'll talk about how that works when we're dividing. And then our last one is our absolute value bars, also another grouping symbol. Our E in GEMS stands for our exponents. So when you have a power where you have a value raised to an exponent, that is our exponent. And so that's the second thing you will be looking for. Next, M. It actually stands for both multiplication and division because you do those in order from left to right. So you don't do them in order of multiplication first and then division. I know that's a common misconception. You just, whatever comes first, left to right. And then lastly, the S, once again, stands for both addition and subtraction in order from left to right. So those are your order of operations. So we're going to go to our first example, and I'm going to start with something really, really basic. And once again, this is a problem I saw on Facebook just the other day, and I had a bunch of people arguing, and it's kind of interesting to see that people don't quite understand why we use order of operations. But the purpose of order of operations is so that when we have a multi-operational expression or problem, we all get the same answer, and there's no arguing. It also, the purpose, or another purpose of order of operations, is so that when I'm writing an algebraic expression, I know how to properly write it so that I can let other people get the same answer that I'm expecting to get. So that's why we use the order of operations, okay? So let's do some practice problems. I'm going to start with something really, really basic and simple, and that is 12 divided by 3 times 4. Okay, this is probably one of the most simple problems you'll see. And you'll notice in this problem, I don't have any grouping symbols, so I don't have to worry about that. I don't have any exponents, but I do have multiplication and division. And the multiplication and division says I do it in order from left to right. So the first thing I'm going to do is my 12 divided by 3, and that is equal to 4. And now I can bring down my next multiplication, so times 4, and I get 4 times 4 is 16. The reason why it is important to use the order of operations in the correct order is because I've seen a lot of people get the number 1 on this because they did the 3 times 4 first because they want to argue multiplication is first, and that is just not correct. If we did 3 times 4 and then 12 divided by 12, we would clearly get the wrong answer. So the person who wrote this problem, number 1, is expecting you to get 16, and when you perform it correctly, you do in fact get 16. Okay, let's do something that's got a few more steps to it. I just kind of wanted to use that as an example of why we use order of operations, but we'll go something a few more steps. So number 2, here we go, our second example. And we're going to go with 5 minus 3 times the quantity, 2 plus 4 to the second power. Okay. So I'm going to start by looking at my order of operations, and I notice that grouping symbols. Do I have grouping symbols here? Yes, I do. I have parentheses. So that means I'm actually going to do what's inside these parentheses first. But what's within those parentheses is multiple operations. So I'm also going to continue following order of operations even inside the parentheses. And I notice that inside those parentheses, I have an addition and I have an exponent. So I'm actually going to do this exponent first. And remember that 4 to the second power means I'm multiplying 4 times itself. So 4 times 4 is 16. And then I'm just going to bring down the rest of the problem. 5 minus 3 times the quantity 2. And now instead of 4 squared, I have plus 16. I still have that grouping symbol there. I still have those parentheses. So 2 plus 16 is what I'm going to do next. There's no other operations there. So 2 plus 16 is 18. And I'm going to keep those parentheses around the 18, even though it's all by itself, because you also remember that parentheses have a couple of different jobs. And while it is a grouping symbol, it is also a way to show multiplication. I am multiplying 3 and 18, okay? So that is my next, so my parentheses are pretty much gone. I'm down to a single number within them, so I'm just going to leave it there. And my next thing, I don't have any more grouping symbols. I don't have any more exponents. Now I'm going to look for multiplication and division. And what do you know? I have multiplication and division, or multiplication right there. So now keep in mind that 3 and that subtraction, it's like saying it's a negative 3. So I'm going to do negative 3 times 18. If you remember, a negative and a positive make it negative. So it's going to remain a negative. And 3 times 18 is 54, I believe. Okay, so that becomes 54. I'm going to bring down my 5. I am left with 5 minus 54. If I start with 5 and I take away 54, I'm going to be left with a negative 49. Final answer. Okay, example number 3. I think I'm going to end up with about 4 or 5 examples here.
Staff, just a reminder to get your...
Just a little bit of a disruption, no worries. Okay, so example number 3. I am going to do, let's say 12 divided by 3 plus, in parentheses, 9 minus 4, and then that's raised to the second power. Okay, so looking at that problem, once again, my order of operations, starting with grouping symbols. I have a grouping symbol right there with my parentheses. Notice the exponent is outside of those parentheses, so I'm not going to worry about that now. I'm going to just worry about what's inside the parentheses. So 9 minus 4 is 5. Going to keep my parentheses there, even though I've still got a single number there, just in case I need to remember it later for multiplication. raised to the second power, and I'm going to bring everything else down there. Okay, next up, 5 to the second power. So I've got my grouping symbol gone. Now I've got my exponent. So this is what I'm going to actually do next. And 5 to the second power is 5 times 5, or 25. That's taken care of. Now, once again, bring everything else down. Divided by 3. I could put parentheses around that. I don't need to because I've got this addition symbol right there. So at this point, the parentheses will not really do a whole lot for me other than saying, hey, look, it's a 25. The addition means that I'm going to add that to it. I don't have to worry about multiplication. I don't really have a negative there that I need it. So I'm going to just drop those parentheses now. Now I'm going to continue following order of operations. I have no more grouping symbols, no more exponents. I have multiplication and division. So there's some division. 12 divided by 3 is 4. 4 plus 25 is what's left. Only operation left, which gives me 29. Okay. Example number 5. Hopefully I can, or number 4, sorry. Hopefully I can fit it on this page. Okay, let's do -3 plus 2 to the second power minus -1 divided by, or over as a fraction, however you want to think about it, -2 plus 5 minus 4. Okay, starting with grouping symbols. As I told you, this fraction bar works as a grouping symbol. So really what it's doing is it's grouping all of these values and operations in the numerator together and all of these values and operations in the denominator together. So we're actually going to kind of work this as numerator first and then denominator, and then we'll worry about our division last. So looking at the top grouping symbol, it's all grouped together. So now I'm going to continue looking at my exponents. So I've got 2 to the second power, which gives me a 4. And I've still got -3 plus 4 minus -1. Now, I do have another parenthesis there, but that one is really just saying, look at me, I'm negative. So I'm not going to worry about those parentheses. And then I'm just going to bring down everything on the bottom for right now. I'll address that later. Okay. So now looking at the top, it looks like I don't have any other multiplication or division at the moment. Once again, I've still got the fraction bar, so this is still grouped together. This is still grouped together. So now I am going to just work left to right with addition and subtraction. So first thing I've got in my numerator is -3 plus 4. Remember, so if I have a -3 and I add it to, or I add 4 to that, I'm going to end up with a 1. You could also flip those, or like Mr. Cummings said the other day, 4 minus 3 is still 1. And then take away a -1, still is there. Denominator, I'm once again left to right. -2 plus 5 is 3. So I'm going to have 3 minus 4. Okay. Now we're going to kind of finish this up. I've only got one operation left on top, one operation left in my denominator on the bottom. So 1 minus a -1. Remember, Mr. Cummings talked about how, remember, when you have two negatives, you're taking away your debt, which really is the same thing as adding. So 1 plus 1 is 2. And then 3 minus 4 on the top bottom, that is a -1. And we're going to take that one step further. Now I can do my division. I'm left with a single term in both my groupings of the numerator and denominator. 2 divided by -1. Positive divided by a negative is a negative. 2 divided by 1 is 2. And that is my final answer. Okay, I'm going to do one more example, and that's just because I want to remind you guys what to do with absolute value, since that is part of our grouping symbols. So we're going to do an absolute value example. Normally, I don't use the back of pages, but I'm going to use the back of this one really quick because I ran out of space on the front. That's the only downside to these composition books, is they're a little bit smaller sheets of paper. But example 5, let's do 13 minus 2 times the absolute value of 5 minus 2 times the quantity of 9 minus 7, final absolute value sign. Okay, So going back to order of operations, I'm looking for grouping symbols. I have two sets of grouping symbols. I have the absolute value and then these parentheses. So we're going to start with the biggest grouping, and that's going to be what's in between the absolute value signs. Okay, awesome. Now within that absolute value sign, I see I'm going to follow order of operations within that, and I see that I have these parentheses. So I'm going to actually do that part first. So 9 minus 7 is 2. And then I'm going to keep my parentheses because notice how I have no operation symbol in between these. So that means it's multiplication. And if you just wanted to take away the parentheses and change it to multiplication, you could do that as well. Keep my absolute value bars and then continue. Okay, still working within our grouping symbol of the absolute value. I've got subtraction between these two and I've got multiplication between these two. So I'm going to do that multiplication first. -2 times 2 is -4. Oops, the yellow doesn't look bad, but we're going to keep it consistent. So I still have 5 minus 4 there. Keep that. -2 and 13 are still on the outside. Okay, we're good to go there. Okay, now I'm down to my absolute value symbols as being my only grouping symbol remaining. So I'm going to go ahead and continue. 5 minus 4 happens to be a 1. So I want to know what the absolute value of 1 is. And then continue from there. And remember, absolute value. Maybe this is another word we need to define really quickly. Absolute value is how far a number is from 0 on the number line. Okay, how far from 0 on the number line? So in case you forgot, there it is. How far is 1 from 0 on the number line? It is 1 unit away. So I'm going to now change those absolute value bars to multiplication because I don't have any operation here between the -2 and the absolute value. So that's like saying I'm multiplying there, just like we would if it was parentheses. And I'm left with 13 minus 2 times 1. Multiplication is next. So -2 times 1 is still -2. And 13 minus 2 is 11. Final answer. I know this was a long video, but thank you for your patience. I promise you it is worth it. Have a great rest of your day, and I'll see you later.